Okay, welcome back. As mentioned at the earlier section, I would like to show you by today how you can improve the accuracy of the recorded path for even more complex purposes, where we will not use only one single point, but we will really use a frame. One drawback or one challenge of this method, you can't do this only with an easy recorded outline. You really need the points as well from the original recording of the frame, so with which we can define a frame. I will show you and you will understand soon everything. So first I would like to show you, so within this recipe, the robot movement is as follows. We are just coming to the P1, so this is a kind of midpoint, and then we will come to the origin. From the origin we will draw follow the x-axis. Then we will come back here to the mid. This will be P4. From the middle we will come back to the origin and we will follow the y-axis. Okay, and this is exactly what we will use. So we have the origin, the x and the y-axis points, and once the axis is covered, then we just come back here again, and then we will start with the real recording of the our path. Okay, just make it a little bit faster. Bam. All right, so what we will need for this demonstration, we will need the origin point, we will need the x and the y-axis. So therefore I really recommend you in the future, if you are doing complex tasks, that you after the initial touching of these points during the recording, you just simply record these 3 points additionally of the frame, because with this one we can make any kind of very complex adjustment later on. So in our special case, this is the P2, the point 2, the point 3 and the point 6, which are defining this is the point 2, point 3 and the point 6. So origin, x and y. So what we should do right now, the recording is already so as it is, so we can't change anything on this. What you should do, you should go with the physical robot, with the tool, exactly to the origin, and then I would like to ask you that you just simply add a new target. So you navigate to the origin point, you just add a new target. Here's the new target, and once the new target is added, you just hit the get position. So the position of the physical robot will be read out and will be transferred directly to RobotDK. And once the robot here on the screen moved to the correct point, then right click and teach current position. We should repeat it with the P3 and the P6. So you should go to the X and you should go to the Y, and exactly the same, you just add a new target, get position and teach it. So I will just fake you these points for our lesson here, that I can show you how it should work. And just to make it a little bit real life ready, I just copy the coordinates of these points here. Okay, Then we need the P3. The P3 should be this one, and the P6 is our y-axis point. P6 will be this one. Okay, I just close all of these windows, and I just create any kind of strange offset for this demonstration. Okay, so this offset will be not so constant as with the other one, but we will really use here a bigger offset on different kind of parameters. Okay, and the last one is, let me say, this should be Z, sorry, with an orientation and maybe some on the X. Okay, great. So we can see that we have pretty different waypoints compared to our original one. And yeah, there is a fair offset. I just check out again if I can still make it a little bit more. Yeah, okay. We will do this in this way, that we can see a little bit more on the. Oh, this was a mistake from me, because we just want to modify this one. Okay, and here again. Okay, so now we should be able to see that we really have offsets between all of this, the P2 to target 96, and so on and so on. I rename them reference origin. This should be our reference X, and this should be our reference Y. Okay, this is very crucial that we do not mess up anything. So, and right now, because we are still in the frame, we are still in our working frame, I just hit the right click, so all of three are selected, and I change support and I put them to the vert coordinate system of the robot. So you will be able to see the position is exactly the same, but the reference is not anymore our frame here, but the reference is the base coordinate system of the robot. So what we do additionally, we select the base coordinate system of the robot, and we add a new frame, and this will be our alignment frame. So, and this frame will be right now defined. We just select the define reference frame, and we just select the 3-point method. First we go to the origin, and we just read in the origin values. Then we go to the X, we just read the X values, and we go to the Y, and we read out the Y values. So once again, these 3 points, these will be created on a manner that we are navigating really to the points, to the real reference origin, to the real reference X, and to the real reference Y points, which we used earlier for the frame definition here as well. And we just adding these new targets. We just get the position from the robot and we teach these new targets. So we will have the real world new coordinates, reference coordinates for this frame. Okay, and with these 3 points, we are just creating this new alignment frame. So I just hit update. And you can see here that the frame and the alignment frame, there is a big difference between the both of them. And this is the offset what we want to apply. So right now, we will do the same trick what we have done. So we just select our improve accuracy tool. Once again, we don't want to copy it. We just really want to move all of the points. And in this case, I select the complete frame. So on this frame, all of the previous recording is stored. Okay, so I select the frame, and this is the get selected object. This is the frame. The from frame is still our frame, so this was our origin. And the to, the destination, this is the alignment frame. And if I hit execute, then with this direction and with this orientation difference, you can see here, compared from this one to this one, you will see that all of these points will be changed, and this is exactly the manner how we have it with the new reference frame. Right now you can see that the frame and the alignment frame are on the same position again, and we have all of the new points we have exactly there where we want it to have. You can delete the edit features as the program is still the same. It is just shifted and rotated into the right direction. With this method, you can really make very complex afterwork, and it helps you to improve the accuracy on very complex outlines. Nevertheless, we still recommend that you are not creating huge recordings at one, but you really put it into segments, and then each segment can be offset, can be manipulated afterwards easily. But you can see that this is a very powerful method how you can really shift earlier recordings to a completely new place, so that even the orientation and the rotation will be changed. I hope it will help you in the future, and stay tuned to the next lessons.